Hello, thank you for joining us today for our webinar on pre-startup safety review. I am Mark Yukich, U.S. Technical Development Manager at Sigma-HSE, and I will be your host today. I have about 10 years of process safety industry experience. That experience includes combustible dust, flammable vapor, and chemical reaction hazards, and steps to mitigate those hazardous materials in process. I always enjoy taking the time to understand the pain points for our customers related to process safety. If we don't have the option to assist, I want to ensure we hand you off to a team we trust to bring value to your safety team. Always feel free to contact me should you need any assistance. Sigma-HSE is a global engineering firm with technical experts supporting companies around the world to provide actionable solutions to protect, enhance, and optimize their process. We provide actionable risk assessments and testing solutions so you can focus on what really matters: protection for your people, business, workplace, and the environment. In this webinar, we will discuss the Pre-Startup Safety Review, or PSSR, which is a systematic approach to ensure safety and operational requirements are met before launching a new or modified process, system, or facility. PSSR helps organizations prevent accidents and maintain compliance with OSHA safety regulations. We will have time for Q&A at the end of the session. Feel free to add questions to the questions section during the training, and we will address those questions at the end of our program. Doug Gruder will be our process safety consultant leading our discussion today. Doug, I'll turn it over to you.
Thank you, Mark. My name is Doug Gruder. I have about 13 years experience in hands-on PSM and EHS, 14 additional years in process engineering and operations management, and 8 years in process control. Today, we're going to be discussing pre-startup safety reviews, as Mark has indicated. What we'll be covering during this session are the different elements of process safety management, specifically PSSR, the OSHA requirements for 1910-119I, which is PSSR, potential startup and shutdown, restarts, problems that can occur, the requirements, why and when we conduct and how we conduct PSSRs. And the how we conduct is going to be a little more detailed. What we should be putting together prior to conducting the review, and then what we do during the review. And very important is the post-review documentation, where we let everybody involved know, especially upper management, what the findings were and what we were doing to resolve those findings. So if you look at the elements of a process safety management system, PSSR falls under operational readiness. And that's number 14 out of the 20 different elements that are required. Operational readiness and all of these different elements do not stand alone, okay? They all interact and they are all needed. The OSHA regulation on PSSR is there to ensure that the startup of new or modified facilities occurs safely. And for that to happen, everything that we're discussing here should be in place before the unit is started up, and certainly before the project is closed. Some of the requirements for a PSSR are to review the construction and the equipment installation and ensure that they meet the design specifications. Project engineer may have ordered a pump, process safety relief valve, and not looked at what they actually got in the plant. So part of the PSSR is to do field verification with that. We also want to ensure that the procedures are in place, and those include operating, maintenance, and emergency procedures. Potentially very big part of the review would be to ensure that any recommendations established during the PHA are in place. And that includes interlocks and basic process control systems that keep the process within the safe operating limits. Modified facilities will have to meet all the requirements, and training of each employee must be completed. Some of the requirements and objectives are to ensure that all the hazards have been identified, evaluated, and mitigated. And this applies to new facilities and to any modified facilities when the process safety information, as required by OSHA, has changed. Some potential problems we see during startup are new equipment is more likely to fail. So if you remember the bathtub curve in the mechanical integrity webinar, mechanical equipment fails at the beginning of its life cycle and at the end. So this is where you can run into some problems. Some hidden hazards from the installation will start to reveal themselves. If valves are put in inaccessible places where the operator has to climb around different things to get to them, that could be a problem. You're also going to have an increased number of people involved and exposed to the hazards. If you put a piece of equipment or a unit operation in a different area of the facility, you're probably going to want to ensure that a facility siting study is done. It increases the potential for human failures because it's a new operation and people are inexperienced. Also, there may be hazardous materials that are new to the site and people will be working with for the first time. Depending on the project team, there may be limited availability of critical spare parts. This review should catch any additional equipment that needs to be ordered. And then we have the pressures on the PSSR team, the time constraints, okay, and the pressure to complete the startup so that the new unit operation can start making money for the company. An example of a poorly managed startup is shown here. And this is an example of unintended consequences. So what this company did is they put in an activated carbon bed for environmental control. That carbon bed took the vapors off of 3 flammable solvent storage tanks. And what was missed here, whether it was in the HAZOP or if it was during the PSSR, was that they did not put flame arresters on the tanks going to the carbon bed. When a new carbon bed first sees solvents, it heats up. And in this case, cooling was insufficient as recommended by the manufacturer. The carbon bed ignited the solvent vapors, which led to an explosion in all 3 connected tanks. This fire spread to other tanks because the firefighting system was not installed. So this is an example where a good intention to prevent pollution actually led to an environmental disaster. Another example of this is Imperial Sugar in Georgia. In this case, the sugar was transferred from silos to the manufacturing unit on a conveyor. And in order to not get external material in the sugar for quality food safety purposes, the conveyor was enclosed. The enclosed conveyor led to the sugar being above its minimum explosive concentration, or MEC. There was an ignition source somewhere in the conveying system that was never identified due to the severity of the explosion. This resulted in a big explosion that not only killed people, but shut down the plant for quite a bit of time. So why do we conduct a PSSR? And these are all the OSHA requirements as listed in 1910 119I to confirm that construction and equipment is in accordance with design specifications, that all of your procedures are in place and adequate, and EHS checklists and PHAs have been done, and that, more importantly, all the recommendations have been implemented or resolved. Training is an important part and should be well underway, if not completed, at this stage of the project. And then there's a final check on all applicable safety, health, and environmental regulations. And this is why it takes a multidisciplinary team. So when do we do it? Well, when the when the project is near or complete, close to startup, but before commissioning. And how do we conduct? Two parts to this. Prior to the PSSR, we have to identify the team, the scope, and the timing, compile all the process safety information, and then schedule. We want to make sure that we schedule to allow enough time to get through it. During the actual PSSR, we'll be doing a project overview, a document review, field verification, which is very important and often reveals some deficiencies. Then we want to put together all the findings and prioritize them, have a bit of a debrief, and prepare a report to get to upper management. So, going step by step through this, we have to identify the team members. It has to be a multidisciplinary team. There should be a supervisor or a technical person that knows the equipment that was installed. Certainly a maintenance representative, an operator, a safety representative, and an environmental. For larger projects, we may want to also include an instrument tech and somebody from quality control. And these should be determined as warranted. Compiling the process safety information. This is very important so that everybody understands the changes that were made. P&IDs may not be completely developed at this point, but we certainly want a process flow diagram. The chemicals that are being used, all of the operating training outlines and SOPs. We want a summary of the PHA recommendations that we're going to ensure are implemented. And then we want to make sure that the basis of safety of the unit operation is maintained and is in compliance with all operating and environmental regulations. We also want to schedule the PSSR. And it's important to allow enough time to complete it. For very large projects, the PSSR can actually progress as unit operations are completed. So if you fit in one piece of kit and the project team is done with that, you can start the PSSR before the whole commissioning is ready to happen. This saves a lot of time, potentially, and gives the project and the PSSR team time to identify deficiencies and get things corrected as needed. So how does the PSSR happen? What are the different steps in it? The project should be articulated to the PSSR team by the project manager. with an overview of the project purpose, site locations and materials, design standards used, any physical or chemical hazards that have been introduced, any FEMAs or PHAs that have been conducted with the summarized findings, the basis of safety for the equipment, and the environmental aspects. And if there are any permitting issues can become a delay if you have to wait on getting permits to start up a new operation. We also want to look at industrial hygiene concerns. And that's because if we're introducing a new solvent into a plant, the PSM focus may have only looked at fire and explosion, while the industrial hygiene limits for that solvent or chemical may be much lower than the lower flammability limit. So we have to take into account personnel exposure. And then we want to make sure that all the recommendations from the previous reviews have been implemented. As far as document review, we want to go through the operating, emergency, and maintenance instructions and have a discussion with the team to ensure that they are adequate and in place. After that, we usually go out into the plant and do a field verification. This is usually done with checklists. If it's a big project, you can divide the team up into equipment types and assign groups. Using the checklist as a guide and bringing in your personal experiences and history, you want to review the installation against specifications and the design practices. You also want to look at the different interface areas for safety concerns. An example of this would be that if you put a new unit operation next to an existing unit operation, how can that new unit operation affect the personnel or the equipment in the adjacent one? Finally, we want to capture all of the concerns and have them documented so they can be reviewed with the team. Now we take those concerns and we develop and prioritize them. Team decides on the method to address them, and then you really want to break them up into at least 2 categories. Those concerns that need to be resolved prior to startup, and those concerns that need to be resolved before the project is closed, but are not critical to the safety of the operation. And that may include things such as painting, signage, but all of these should be captured under management of change so that we don't lose sight of the risk that we are starting with. And we can easily determine the increased risk, and the company will set some criteria by taking those safeguards and the probability of failure on demand credit for them out of the HAZOP scenario and seeing what it raises it to. So this is how we prioritize and rank the different risks. And from there, we determine what is an acceptable risk to start up with and what is not an acceptable risk to start up with. And this is all based on the specific company's acceptable risk criteria. Next, we're going to talk a little about the debrief, the closing conference. So the team presents the report to the project team and production management, including the operators of the new equipment, because those are the individuals that are going to have hands-on interaction. You also want to document the prioritized recommendations and solutions and develop smart actions to resolve them. Those actions need to be specific, measurable, attainable, realistic, and timely. Then we'll distribute the report. And I will go a little into how to prepare the report on the next slide. But it needs to be distributed in a timely manner. Our report should contain a number of things, right? The format of the report is shown here. Certainly you want the dates of the reviews, the team that did the review, the boundaries, the process and equipment that was reviewed, along with the list of recommendations. And those recommendations should be assigned to people or departments and tracked to completion. Every company has different distribution requirements, but for a small project, it may just be plant management. For a larger project, we may want to include plant management along with sector presidents and some VPs. Any revisions should be tracked in a system. The recommendations should be tracked. And as I said previously, they should be split up into what needs to be done before startup and what can wait a reasonable amount of time after startup. And this report, the PSSR report, should be retained for the life of the process. To continue with report preparation, the report needs to include what action items need to be taken care of before commissioning, and those would include all the high-risk recommendations and low-risk recommendations that should be covered by an MOC if they are not implemented before startup. all recommendations should be completed before the project closeout. Okay, and this encourages the project team to not just move on to the next project and leave some missing items not accounted for. Some takeaways. The PSSR is important, and it is your last safety review before project startup. A lot of process incidents have occurred because of inadequate PSSRs, and we mentioned 2 of them earlier in the presentation. Starting up the process is usually under considerable time pressure. So you want to make sure that if you can start the PSSR as different unit operations in a big project are completed, you get a jump on those. You have to have the allocated resources, funding, and especially the schedule. And this should be thought through and included in the project timeline. And existing startup safety reviews are not just a rubber stamp or a go out in the field and go, yeah, that's there, that's there. They require additional guidance and training, usually accomplished or done by the process safety engineer at the site to the process and project teams. So it's not something that should be rushed through, and a significant amount of time, depending on the scope and size of the project, needs to be allocated. Next, I'll be turning the presentation back over to Mark for any questions.
Thank you, Doug. I appreciate it. Good work. If you have any, once again, if you have any questions, please add them to the questions section on the right hand of your screen, and we can work on getting you an answer. One question that's in here, Doug, is are there templates that are available for sections of the PSSR?
Yes, there are, and those I would refer to as checklists. There are numerous checklists that different companies have. We at Sigma have a very inclusive checklist, and it's set up so that different sections can be ignored if the project did not include that specific set of questions. But yes.
Excellent. Thanks, Doug. Can you share examples of common gaps identified during PSSRs that would otherwise go unnoticed without that review?
Yeah, I've seen a number of them, and I guess the biggest, the one that's most hidden is the basic process control system or safety instrumented system interlocks. They should be tested to ensure that they work as designed. As in our example, flame arresters and other safety equipment being missed either during the PHA or their installation being missed as during the field verification. SOPs not being completed is a common one, and training is also something that may take a little longer and can be done after the startup, but before the project closure, as long as there is a qualified operator or mechanic on site and with the trainees during that time.